Hello everyone, this is Eduperiodic and welcome to all. Today we discuss about matter and its interactions. And today topic is phase transition. And what is phase transition? We already study about that matter has four states. And when a phase transition occurs when a physical and chemical changes, when a substance undergoes a transformation from one phase or state of matter to another. These changes can happen due to alteration in um, temperature and pressure and other conditions, other external conditions. The most common phase transition involve changes between solid, liquid, and gas states. And nowadays, a fourth state also consider. So let's see one by one all transition. First one I take that is melting. In melting, transition occurs solid to liquid state. What is melting? This transition occurs when a solid substance gains enough thermal energy to break its intermolecular bonds and become a liquid. The temperature at which this occurs is called the melting point. Okay, so if I take some example, the first example is ice cream from solid cream to liquid water and melting of ice, that is, and melting of candle and melting of butter are very common example of this transition. Okay, next question I have that what temperature does ice melt? A very common example. Melting a point of ice at 1 atmosphere of pressure is very close to 0 degrees Celsius, that is also 32 degree Fahrenheit and 273 Kelvin. So this is also known as the ice point. Okay. Yes. Next transition we take that is freezing. And in this transition, liquid state transform into solid state. That what is freezing? In this transition, a liquid substance lose thermal energy, causing its particles to slow down from stable intermolecular bonds, turning it into a solid. The temperature at which this occurs is the freezing point. And if I take some example of freezing, that is snowfall and sea ice, frozen food also in freezing, and lava hardening into solid rock, and solidification of melted candle wax. Normally, freezing and melting points are similar to each other because they are interconvergent state. Okay, I have a one question here that is what is the freezing point of water? The freezing point of water is 0 degrees Celsius, that equal to 32 degree Fahrenheit at standard atmospheric pressure, which is 1 atmosphere or 101.3 kilopascal. Okay, so it's a basic example of freezing, and if we see both temperature are equal to each other, that means melting and freezing temperature are equal. That means solid to liquid and liquid to solid states represent here. Okay. Next I take that is vaporization, and this is liquid to gas transformation. So what is vaporization? When a liquid absorbs enough thermal energy, its particle gain sufficient kinetic energy to overcome intermolecular forces and become gas. Evaporation occurs at the liquid surface at any temperature, while boiling is a specific cause of vaporization that happened at the boiling point. Okay, if I take example, the first example is simple wet clothes drying under the sun or in a dryer. Second one is salt being recovered from seawater by evaporation. That is the example of evaporation. Further, I discuss about evaporation and boiling differences. The third one example is moisture in the atmosphere and clouds being formed by water. So cloud formation is also a common example of vaporization. Heated pools losing water by vaporization. Okay, water boiling and sweating. So here are some interesting and common example to show process of vaporization in daily lives. Okay, here are two modes of vaporization exist. First one, that is evaporation. And what is evaporation? So evaporation occurs at the surface of a solid. It's easy to learn. Surface of a solid, and evaporation occur at the surface of a solid, surface of a liquid. Evaporation is very slow and less vigorous process compared to boiling. Okay. The what is boiling? Boiling is the rapid and vigorous vaporization of a liquid that occurs when the liquid reaches its boiling point. The boiling point is the temperature at which the vapor pressure of the liquid, the external pressure, usually atmospheric pressure, and unlike evaporation, boiling happen throughout the entire volume of the liquid. Here are the main difference between boiling and vaporization. We already see here evaporation only occurs at surface of a liquid, surface of a liquid. Okay, so yes, vaporization exists in two forms, evaporation and boiling. Boiling is refers to as boiling point when vapor pressure of liquid equal to atmospheric pressure, and evaporation only occurs at surface of a liquid. Okay, so next question I have there is boiling. What is boiling point of water? The normal boiling point of water is 100 degrees Celsius. We also say that 212 degree Fahrenheit at pressure of 1 atmosphere. Okay, and we also convert it into kilopascal, which is the standard sea level atmospheric pressure. So yes, boiling point of water is 100 degree Celsius. Okay, I hope you understand this. Okay, next phase I take, that is condensation, and in this phase gas transfer to a liquid. That what is condensation? In this transition a gas lose thermal energy, causing its particle to slow down, and for intermolecular bonds and formation of a liquid. Condensation is the reverse processes of vaporization. So yes, this is opposite process of vaporization. If I take some example, then I see dew forms in the morning on leaves and grass because the warmer or air deposit water molecule on the cool leaves. Okay. The next one is in the morning. We see the mirror in the bathroom during a shower becomes foggy. Also example of condensation. Because warmer water vapor in the air hits the cooler surface of the mirror. Okay, that is the reason. Next example is cloud formed by condensation. Warmer air comes into contact with cooler dust particle and the vapor deposit into a liquid. On those particles form clouds. So yes, formation of clouds include both process and its result as the rain in the earth due to vaporization and condensation process. Both involved in process of formation of rain. Okay, next transition I take, that is sublimation, and this transition undergoes solid to gas state. So what is sublimation? Some substance can transition directly from a solid to gas phase without passing through the liquid phase. This process is called sublimation. That means when a solid state directly goes into gas without change into liquid state, that is called sublimation. Okay, solid goes into gas state directly. Here are some example. The most common example, that is dry ice, that also is frozen form of carbon dioxide. When it convert into gas, carbon dioxide is example of sublimation. Second example, that some printers use sublimation to transfer ink from a solid sheet to a paper. Very important example. And creating high quality images that are resistant to fading. Okay, so it's interesting. And most common example that all one remember is naphthalene balls. When we use naphthalene ball in house, and these naphthalene balls also sublimate room temperature and pressure, releasing a pungent smell to repel insect. We use it so we can see a sublimation in naphthalene balls at home. Okay. Next transition I take, that is deposition, and this state gas to solid transition. That what is deposition? Similar to sublimation, deposition is the process when a gas transforms directly into a solid without going through the liquid phase. And the example, if I take, that is frost and snow and soot are common example of deposition in nature's and everyday life. And depositions can also be used to make dry ice. Okay, and ammonium sulfate and ammonium nitrate, that is industrial uses. So yes, these three states are here. When solid state change into liquid and the liquid state change into solid, and there are total 6 transition in 3 state consider, and these all transition are very important to understand matter and their properties. And next important state that I take, that is ionization, and this state gas state change into plasma. And that what is ionization? Ionization is the process by which atoms or molecules lose or gain electrons. In this stage, molecule of, if I take one example, if that is gas molecule, then if it is lose their electrons or gain electrons, lose electron or gain electrons, resulting in the formation of ions. Two types of ion here form. When a gas undergoes ionization and transform into a plasma, the atoms or molecule in the gas gain enough energy to break their outer electron away from their nuclei. This lead to the creation of positively charged here, positively charged ions and negatively charged ions. This is also called free ion, negatively charged ion. As a result, the gas become a mixture of positive charge and free electrons, which collecting form a plasma. So basically, when gas, atoms or molecule create positive and negatively charged anions, and a mixture of positively and negatively charged anions is called plasma state. Okay, and there are many ionization are available in chemistry to in various fields like thermal ionization, photoionization, and it's also used in electric field. Okay, yes, it is interesting to understand this process, and this is very important. So next one is deionization. So yes, this is opposite to ionization in their plasma to gas state. Okay, so what is deionization? Deionization is a process that remove ions. So when we in ionization process, positively and negatively charged anions form, but in this state, the process of removing the ions is called deionization. The main concept of deionization does not directly apply to transforming plasma back into gas. So basically, we cannot change plasma state directly to gas state because there are three steps and many more states are available to do this process: recombination process and cooling and reducing the energy input. And when these three states apply, then plasma state undergoes to gas. So, plasma is a distinct state of matter that consists of ions and free electrons, while gases are made up of neutral ions or molecule or atoms. So, transitioning from plasma to gas involve the recombination process and typically require the plasma to lose energy, which can happen through various mechanisms like cooling and reducing the energy input. Okay, as the ions and electron recombine, the plasma ionization state dismiss and the gas return to a neutral state. The best example of deionization, if I take that, is the process of removing ions from a solution, and this process we use to produce highly purified water by removing both positive and negative charge ion from the water, resulting in a water product that has a very low conductivity and more purified before. Then, okay, so plasma deionization state is important for water treatment. It's very important. Okay, that's it. These all eight states, eight transitions are we discuss here. I hope this video is helpful for all of you. If this helpful, please like, share and subscribe to this channel for more videos that I made for you. Till then, take care.